have him here in our seminar series. Marc is an associate professor at the University of Ottawa in Canada. He did his BA in anthropology and his MA in linguistics at the University of Montreal. And he did his PhD in linguistics at Cornell University. He had a short stint as a lecturer at the University of Michigan, but otherwise he's been at the University of Ottawa since 2006. He's also an adjunct professor at the Hanoi University of Social Sciences and the Hanoi University of Science and Technology. He is on the editorial board of the Studies in Laboratory Phonology series, on the editorial board of the Journal of the Southeast Asian Linguistics Society, and of the Cahier de Linguistique Asie-Orientale. He has published in a variety of journals, in the Journal of Phonetics, Journal of the International Phonetic Association, Language and Linguistics Compass, Diachronica, Journal of the Acoustical Society of America, Linguistic Review, Journal of the Southeast Asian Linguistics Society, Language Documentation and Conservation, Mon Khmer Studies, and of course the Cahier de Linguistique Asie-Orientale, as well as a Vietnamese journal that I'm not sure I want to pronounce, Ngon Ngu. How do you say that?
Almost. Ngon Ngu.
Ah, Ngon Ngu. Okay, something like that.
Pretty good.
Okay. Oh, thank you. So I'm really pleased he's able to give us this talk. I managed to convince him. He gave a shorter version of this talk at the Laboratory Phonology Conference held virtually in Vancouver. And he's giving us a longer version. And it's a talk that I think will tick all of our boxes. It's phonetics, it's sound change, and it's Southeast Asian languages. So thank you so much for joining us, Marc. We really, really appreciate it.
Thank you for inviting me. So I'll try to give this as a regular talk, but if you have clarification questions, if there's anything I mentioned in the talk that is not clear, you can probably ask me the question right away in the group chat. And for more elaborate questions, you can keep them for the end. So I'll share my screen. Okay, can you see my presentation? Okay, I assume you can. Okay. Sorry about this. Okay, so I'll start. So before starting my talk proper, I would like to thank some collaborators who have been involved at various stages of this project. The main two collaborators are my PhD student, Ta Tang Tan, who has helped me with data collection, data processing, analysis, but who's been more and more involved in the intellectual planning of this project and who is really becoming a collaborator over the years. And I'd like to thank James Kirby from the University of Edinburgh, who is my project partner. So I'm going to present data today that is mostly from languages spoken in Vietnam and Cambodia, but James is also collecting data from languages of Thailand and from Burma for this project, and eventually all of this will come together to give us a big picture of voicing and register contrast in Mon Khmer and Chamic throughout Southeast Asia. There's also a number of Vietnamese linguists and Cambodian linguists without whom this project wouldn't have been possible. So every time I go to the field, usually there are local linguists helping me. And I'd also like to thank a few research assistants who are working in my lab in Ottawa. Okay, so I'll set the picture first. So a voicing contrast and onset stops is reconstructed for both Proto-Mon Khmer and for Proto-Chamic. So on the map here, you can see Mon Khmer in red, and it's found throughout Southeast Asia, although there's definitely more Mon Khmer languages in the east. And then you also have Chamic languages in orangish, brownish here. You also have a few Cham dialects in Cambodia. Okay, so Chamic is an Austronesian language, but Chamic languages have split from the rest of Austronesian about 2,500 years ago. So despite the fact that Proto-Mon Khmer and Proto-Chamic are are assumed, are reconstructed with a voicing contrast and onset stops. Most of their daughter languages have replaced this voicing contrast with a register contrast. And I'll give you more details on the next slide, but register is a contrast that is realized primarily on the vowel and that is cued by multiple phonetic dimensions such as pitch, voice quality, and vowel quality. Now, why is proto-voicing or voicing reconstructed in Proto-Montkhmer and Proto-Cham, despite the fact that most of their daughter languages have register contrasts? It's largely because the classical Southeast Asian languages like Mon, Khmer, and Cham use the graphemes that represent voice stops in Indic languages or Indic scripts to denote the low register. So for this reason, it's usually assumed that at the time when these languages borrowed the Indic scripts, they had voice stops, and that these voice stops then became a register contrast. So I'll give you a better idea of what register is. So register is a contrastive bundle of acoustic properties that develops from the loss of voicing in onset obstruents. And in Montkhmer and the Chamic, onset obstruents are primarily stops. There's very few fricatives. So you typically start with a contrast in which you have voiced obstruents and voiceless obstruents. Let's take ba and pa as examples. And then while pa remains pa, ba loses its voicing and develops a low register on the vowel a that is marked here with the subscript circle. So the low register on that syllable, or the vowel of the low register syllable, takes on a lower pitch than the vowel of the high register. It also takes on a breathy voice quality. It typically has higher onglides or something higher, or sometimes higher vowels, and it can also have longer vowels. The high register, by contrast, the register that derives from voicelessness, has a higher pitch, a more modal or normal voice. It has vowels typically have lower onglides or no diphthongization in the high register, and the high register also has shorter vowels. Now, register is common in Montkhmer and Austronesian. It's found in Chamic, but it's also found are parallel processes or similar processes in Javanese and in Madurese. But there are also things that look like register in East Africa, in Nilotic languages, and most tonal languages of East Asia have undergone a process that is fairly similar to registrogenesis, or the development of register. So what happened in these languages is that you already had tone, and when the voicing contrast was lost, each tone was split into two tones. So for example, a 3-tone system split into 6 tones as a consequence of the neutralization of the voicing contrast. Okay, so what I'll do next is show you examples of register languages and register contrasts. And at the same time, I'll seize the opportunity to show you on spectrograms how we measure the acoustic properties of register. So I'll start with a Chrau, a language spoken in South Vietnam, and in which you have a register contrast in which you have a variety of acoustic properties that seem to all play a relatively equal role in the register contrast. So I'll first play the examples. So the high register word for hand is, oops, sorry.
Tay.
Okay, high register, I'll play it again.
Tay.
And the low register is
Tê. Tê.
Okay, so first difference you can see between the two registers is that F0 is higher in the high register than in the low register. The second difference that is obvious in the spectrogram is F1. You can see that the first formant at the beginning of the vowel of the high register word is higher than F1 at the beginning of the vowel of the low register word. Another difference that you can probably notice is that there seems to be more aspiration after the stop. The stop is the white part of the spectrogram. So the closure of the stop is silent, so it's white, blank. And then after the closure, you have some aspiration in the low register. There appears to be less aspiration in the high register. And then a final difference you can see if you're a trained phonetician is that energy in upper frequencies and in the low register actually has a lower intensity. Okay. Another way of putting this is that the second formant that you can see fairly clearly in the high register is not very clear in the low register word. You can see traces of it, but it's not as dark. Okay, this is an indication that the low register word is breathy. And then this can be better seen by changing the resolution of the spectrogram and by turning it into a narrowband spectrogram. So on this spectrogram here, instead of seeing wide bands, you can see each individual harmonic. And the typical way of calculating or of measuring voice quality is to measure the relative amplitude of a low harmonic and a higher harmonic. So one of these horizontal striations versus one horizontal striation that is higher up. Okay. Apologies. Okay. So there are many ways. I have several questions in the chat room. Just give me a sec. I'm having a hard time getting to the chat room. Give me a second.
Mark, you don't need to worry.
Yes.
It seems like one participant is having trouble seeing the slides advancing, but everyone else can. So
okay.
Yeah.
So there are no questions about the content
nothing for
itself?
you to address.
Okay.
Don't worry.
Okay. Good. Excellent.
Mark, do you want me to interrupt you if there's a question to address right now, or do you want to wait till the end?
No, that would be excellent. If there are clarification questions, please interrupt me right away.
Okay, yep, thanks, Mark. Stephen, you or I should keep an eye on the chat in that case. Okay?
Excellent. Okay, so I'll go back to, to the measurement of voice quality. So how will I measure voice quality here? What I will do is to focus on one measure, and this measure consists in taking the differential in intensity to a measuring of the difference in intensity between the first harmonic, H1, and the second harmonic, H2. Okay, I could get a similar measurement by measuring the difference between H1 and a much higher harmonic, or by measuring the difference between H1, the first harmonic, and the peak harmonic of one of the formants. But it turns out that most of the time, all these spectral balance measures, because that's how they're called collectively, all these measures tend to be correlated. So for this presentation, I'll focus on H1 minus H2. What matters here, if you're not a phonetician, is that a low H1 minus H2 is an indication of modal voice, and that a high H1 minus H2 is an indication of breathy voice. Okay, so Chrau is a register language in which there are various cues that all seem to play a similar role in terms of quantitatively. I'll show you examples of register languages in which some of the acoustic properties are dominant and play a more important functional role than others. I'll start with Chru, which is a language in which F1 seems to be the most important cue. So here you can see that, well, I'll play the sound samples first. So the word for, you have the word for I first. Oops. Okay, and then you have a quasi-minimal pair, which is the word for duck. Okay, which has two realizations, one with voicing and one without voicing. Okay, so in the word for I here, which is in the high register, you can see that F1 starts relatively low, relatively high, whereas in the low register, F1 starts much lower. Okay, you can see this as the beginning of the vowel. Okay, compare this with this and this. Okay, the red line here, the red line is the pitch track. F0 is a bit higher, is normally on average a bit higher in the high register than in the low register, but it's not obvious in this spectrogram, and the difference is usually fairly small. Another difference that is fairly minor is voice quality. You shouldn't be able to see very clear difference between energy and upper frequencies in the high register word and in the low register tokens. Okay, so F1 has a register system that is largely based, no, Chru has a register system that is largely based on F1. Now, there's something else that is interesting in Chru. There is variation even within speaker in the way in which the consonant itself is realized. You can see here that there's one variant in which you don't have voicing.
Adapt.
Okay, and actually in this word here, you have a slightly positive VOT, so you have a tiny bit of aspiration after the stop. Whereas the same speaker a few minutes later pronounces the same word with voicing.
Adapt.
And you can see this voicing here at the bottom of the closure. So this red bar is an indication that there is a negative VOT, okay? Which means that there are vocal fold vibrations during the stop closure. Okay, so variation here in Chru, the same speaker can pronounce the same word, sometimes with a negative VOT and sometimes with a slightly positive VOT. Okay. I have another example here, an example of another register language, Mon, which is spoken in Burma and also in Thailand. There's a lot of variation in the register systems of Mon dialects, but the dialect I have here, for which I have data here, Ban Nakhon Mon, which is spoken in southern Thailand, has a register system that is largely based on voice quality. There are slight differences in F0. There are slight differences in vowel quality as well, but voice quality is the dominant pattern, as you can hear in these examples.
B, B.
Oops, sorry.
B, B.
Second word.
Sag, 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 sag.
And then.
Clan, clan.
Okay, so the breathiness in the low register words, the second words of each pair, is fairly salient. Sorry. Okay. And then finally, register systems can be organized largely along F0 or along pitch lines. And this is the case in Eastern Cham, a language on which I've done significant work myself. So all Cham dialects have the register distinction, and in all Cham dialects, F0 seems to be playing an important role. So pitch seems to be an important cue. However, in Eastern Cham, it seems that pitch is dominating the other cues. And I'll show you a minimal pair here. I'll play you a minimal pair.
Ba, 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 ba.
Okay, so you can probably hear that pitch is the dominant property of register in this Cham dialect. Okay, now for those of you who are familiar with East Asian languages with complex tone systems, this should remind you of something. So as I mentioned earlier in the presentation, the neutralization of voicing in onset obstruents can trigger a two-way or sometimes even a three-way split in tone systems. So this is something that was first described by André-Georges Audricourt. I found this interesting picture with a funny hat. So what's received knowledge is that when this happens in tonal languages, in languages that already have tonal contrasts, what is gonna, the two-way split is not gonna be, shouldn't be accompanied by voice quality contrast. It should be only pitch-based. Now, we already know that this is not literally true. There's more and more work suggesting that there may be traces of voice quality, but let's say this is an orthodox view of how the loss of the voicing, the loss of the voicing contrast and obstruents contributes to tone systems. Okay, so how does register develop step by step? So this is something that has been studied by various people. And I just realized here that I'm not citing Franklin Huffman, okay, which I should do. So there's an important paper by Franklin Huffman in 1976 on that very topic. So the idea is that you have the contrast on the consonant first, on the onset obstruent, and then that the contrast has secondary properties that are realized on the vowel. Now, these secondary properties are first exaggerated, and then they become phonologized up to the point where you lose the original voicing contrast and only keep the secondary properties, which become contrastive. So at stage 1, you have a voicing contrast on the onset. And then because of the laryngeal settings that you use in the production of the voicing contrast, there are secondary intrinsic acoustic properties that are co-articulated at the beginning of the vowel. At the second stage, these intrinsic acoustic properties get enhanced or exaggerated. And here I represent this with stripes throughout the vowel. But there's another way it could happen. You could just have a magnification or an amplification of the perturbations that are caused by the laryngeal settings in the onset consonant. Then at the next stage, which is very difficult to distinguish from the enhancement stage, you should have redundancy. So you have a strong register, well, you have strong register properties, or the original secondary acoustic properties become very strong and become phonologized on the vowel, but you still preserve the voicing contrast. And at the final stage, you lose the voicing contrast and only keep register on the vowel. So in a way, contrast has moved from the initial consonant to the vowel. Okay, so in the short diachronic scenario I just gave you, it's obvious that the secondary acoustic property of voicing are essential. But what are they exactly? What do we know about the secondary acoustic property of voicing? So most of what we know about these properties comes from Western European languages. There's not very much work on Southeast Asian languages, for example. And then a first thing that needs to be mentioned here is that in some of these languages, like Spanish, most Romance languages, but also Dutch, also some Germanic languages, and most Slavic languages, the voicing contrast is realized in the same way as in Canadian French here. So this is data from a pilot study we conducted in my lab in Ottawa. So in Canadian French, voice stops are realized with a negative VOT, which means that you have voicing during the closure of, during the stop closure. Whereas voiceless stops are realized with a VOT that is overall positive. Doesn't have to be very long, but it has to be above 0, which means that you first release the stop, then have a little bit of aspiration, and then the beginning of the vowel. Now, what are the secondary acoustic properties that are caused by this type of voicing contrast? So first of all, we know that we have a pretty good idea of what's happening with F0 and with formants. So, and the patterns we find seem to roughly correspond to what is found in Montkhmer and Austronesian languages that have developed register. So you typically have a higher F0 immediately after voiceless stops. And this is actually something we've known since the late 19th century. And then you have an F1 that is higher immediately after voiceless stops, which means that you have lower or more open vowels. And this is something that we've known since World War II, since the spectrogram became available. The problem is that it seems that voice quality goes in opposite direction in Western and in Southeast Asian languages. So there's relatively few studies of voice quality after stops in Western European languages, but what we know is that in languages in which voiceless stops are realized with some aspiration, like English or German, you typically have breathier vowels after these voiceless stops than in the voiced series. Okay, there is, if you look at languages in which there is not very much aspiration after voiceless stops, as in French and Spanish, it seems that there is not that much of a difference in voice quality after voiceless and after voice stops. These seem to have comparable voice qualities. this is the opposite of what we should find in a typical voicing system of Southeast Asia, because we know that when voicing is lost in Southeast Asian languages, it is actually the vowels that follow the voice stops that become breathy. Okay, so this raises a question. Is the voicing contrast in mainland Southeast Asia similar to the voicing contrast in the Western European languages? Just a second, my daughter walked into the room. Yeah, well, viens voir si tu veux. Okay. Okay, so how come there is no registrogenesis attested outside Southeast Asia in cases of voicing neutralization? So there are quite a few Western European languages or languages outside Southeast Asia that have lost the voicing contrast. Just give me a second, please. Okay, sorry about this. I feel like the guy on BBC a few years ago. Yes. Okay, so I'll continue. So okay, so we know that in languages that are not languages of Southeast Asia and in which there is a voicing neutralization, there is no registrogenesis developing, which is kind of awkward. So first, there is a number of Dutch dialects in which a voicing contrast is lost in onset stops and onset fricatives. And in Dutch, what you have normally is a clear merger. Nothing is left from the original voicing contrast. In Afrikaans, which is closely related to Dutch, you have a F0 contrast, a pitch contrast that develops. So after voiceless stops, you develop a high tone. After voice stops, you develop a low tone. But the other cues that are typical in register systems don't develop. And there's also a recent thesis on Central Malagash that shows that the loss of the voicing contrast results in something that looks pretty much like Afrikaans. So you have a two-way tone contrast. So this would seem to suggest, once again, that there's something different between voicing in Southeast Asia and voicing outside Southeast Asia. Okay, so now that I've shown you what are the secondary acoustic properties of voicing across language families, I'll give you a short idea, a quick idea of why there are secondary acoustic properties, what the phonetic motivations of these secondary acoustic properties are. So the reason seems to be primarily that it's difficult to produce voicing in an obstruent. So let's take a typical obstruent, a stop. And here on my little chart, I have a closure at the lips. So I'll illustrate the difficulty of producing a voiced obstruent, a voiced stop with a bilabial stop. So in order to produce voicing, you would normally let air flow from the lungs into the oral cavity. Okay, and as air flows through the glottis, the vocal folds are going to start vibrating. They're going to be pushed apart and recoil. So you're going to have the Bernoulli effect that produces voicing. Now, what happens when you're producing a stop is that air pressure will flow into the oral cavity and will quickly build up to the point where there's going to be as much air pressure in the mouth and in the lungs. And since the pressure is going to be equal in the two cavities, air will stop flowing through the vocal folds. So voicing will stop. So if you want to produce a voiced obstruent with constant vocal fold vibrations, what you need to do is add articulatory maneuvers to increase the transglottal airflow and facilitate the maintenance of true voicing. And one mechanism to do this is to lower the larynx. If you lower the larynx, think about it, you're increasing the air pressure in the lungs and you're reducing the air pressure in the oral cavity. So this way you're going to be able to maintain voicing a little longer. Now, it turns out that there is a link between the lowering of the larynx and F0, voice quality, and vowel quality. So the connection with F0 is twofold. And it's illustrated on this chart here that comes from a now seminal paper by Honda et al. So when you lower the larynx, because of the cervical lordosis, or the fact that our necks are not perfectly straight, the angle between the two cartilages, the thyroid and the cricoid cartilages, is gonna tilt, is gonna change a little bit. And since the vocal folds are attached to the front part of the thyroid cartilage and the back part of the cricoid cartilage, they're gonna be less stretched if you lower the larynx. So this way you should produce a lower F0. Another mechanism that has been proposed is that when you have a high larynx, the vocal folds have a good area of contact, which facilitates the Bernoulli effect, the suction effect that allows voicing. But if you lower the larynx, all the soft tissues in the larynx are stretched, and that means that the vocal folds are not going to touch as much, which is going to reduce the efficiency of the Bernoulli effect and should reduce the speed of vibration of the vocal folds, resulting in a lower pitch. Now, what is the effect of larynx lowering on voice quality and vowel quality? So for voice quality, the story seems to revolve around this configuration here. So when you have stretched tissues, the glottis, the vocal folds don't touch as much. So if you have an increased air pressure, there should be some leakage. And this air leakage through the vocal folds should be perceived as a form of breathiness. And then if you lower the larynx, should have an effect on the formant frequencies, because by lowering the larynx, you're lengthening the vocal tract, but you're especially lengthening the back cavity, which is a major acoustic predictor of the first formant. Okay, so this is probably the most robust mechanism, although we have very few studies of larynx lowering in register languages, and even in voicing. We have there's probably 4 or 5 good studies of the effect of larynx lowering, of the presence of larynx lowering in voice stops, but this is not something that is very well understood yet. A second mechanism that could be used to boost the transglottal airflow, or the amount of air flowing through the glottis while producing a voice stop, is to advance the tongue root. If you advance the tongue root, you expand the oral cavity. So this should give you a little more time it should allow you to maintain voicing a little longer. Now, it's been proposed by Ken Gregerson in 1976 that tongue root advancement is the primary strategy to produce register. And he's claiming that it is the case because it's a strategy that is also used to produce voicing. Now, when you think about it, advancing the tongue root should have a direct effect on vowel quality. Some people have claimed that, well, Kingston and all have claimed, like it's just a few lines in a 1997 paper, that there is an indirect chain of causality that could cause a voice quality effect, but this is not very well established. And as far as we know, there is no direct effect of tongue root advancement on F0. Now, so people were very skeptical of the tongue root advancement scenario for several years, but recently there's been some experimental work showing that tongue root advancement is a strategy that is used in the production of voicing. So ON 2018 is looking at English, Brazilian, Portuguese, and Thai. And then she has another study coming up soon in which they show something similar in Mandarin. So it seems that this mechanism is not totally implausible, but it wouldn't be sufficient to account for register because it wouldn't account for voice quality and F0 differences. However, it's very possible that it co-occurs with larynx lowering, that it co-occurs with other strategies, although the only imaging study of register we have so far, which was conducted by Therapan Luangthongkum in Thailand a few years ago, is an X-ray study, and this study doesn't show any difference in terms of tongue root advancement between the two registers. Okay, so I have another slide where I mention other possible mechanisms that could be involved in voicing and explain the development of register, but I think that's enough. I've shown you the main mechanisms, so I'll jump to data from Southeast Asian languages right away. Okay, so the research questions I want to ask today after this long review of knowledge on register and voicing is, first, how is voicing realized in Mon Khmer and Chamic? So does it look like true voicing in other languages, and especially Western European languages, which are relatively well described? Second, if the voicing contrast is preserved, what are its secondary acoustic properties, and do they match what we know about register? And third, if voicing is lost in some of the Southeast Asian languages, is register realized as expected from research on previous register languages? So we decided to collect data on a number of Hmong Khmer and Chamic languages of Southeast Asia. I think in my abstract, I was promising 4 languages, and I managed to collect and measure and analyze data from 7 languages in the past few weeks with the help of my research assistants. So we're going to look at 2 Hmong Khmer languages and 5 Chamic languages. What's common to all these languages is that they are all languages that were described with a voicing contrast and stops in the 60s or 70s. So for all of these languages, we assume that voicing is still present, despite the fact that once in a while, some authors mention that there may be redundant register in these languages. So there are first 2 Hmong Khmer languages, Chrau, which is spoken conveniently close to Ho Chi Minh City, to Saigon, and Nong Ralam, which is inconveniently spoken close to Ban Mit Tuot in central Vietnam. And then the red languages are all Chamic. So you have true Southern Reglai and Northern Reglai, which are spoken in South Central Vietnam, and 2 Jarai dialect, one spoken in Eastern Jarai, which is spoken in Vietnam, and Western Jarai, which is spoken in Cambodia. We built a word list for all these languages. Obviously, the word lists differ in the 7 languages, but they all contain target words which have syllables composed of dental or velar onsets and 5 vowels, 5 similar vowels. In this talk, for the sake of brevity, I'll focus on the most interesting results and will only report on words that start with plain stops. Each word was repeated 4 times in a fixed frame sentence to keep the intonation constant. And obviously frame sentences vary from language to language. And then we recorded both audio and EGG signals. EGG, the electroglottogram, is an instrument that allows you to measure vocal fold vibrations, the degree of vocal fold contact from which you can derive vocal fold vibrations. In this talk, I'll mostly present the results from the audio signal, except for VOT, which was measured from the EGG signal because it's more reliable. Okay, so let's jump into the results. Now, there's something surprising from the start. There's only 1 language in which there is systematic voicing. Okay, all other languages have strong devoicing. So the language that still preserves the voicing contrast is Northern Reglai. So on this chart here, you can see that in Northern Reglai, voiceless stops in red almost always have a positive VOT. You see that there's a few exceptions, but we're talking about a few words. They may be production mistakes. But that the voice stops are largely realized with a negative VOT, meaning that they have vocal fold vibrations during the closure. Now, what's interesting here is that there's still a small proportion of voice stops that are produced without voicing with a positive VOT with some measure of aspiration. But this seems to be a marginal pattern. If we break down results from all the speakers into a chart that gives you individual variation, we see that men tend to realize the voice stops with negative voicing all of the time. So, I mean, most men are very close to 1 to 100% of closure voicing, whereas women tend to be lower. There are some, like women will devoice their voice stops once in a while. There's also, you can see that the x-axis represents age, and there doesn't seem to be very much of an age climb. It seems to be a gender difference. Now, I was having a Skype meeting with one of my MA students who is looking at these results in more detail yesterday, and she's telling me that the method we've been using for Northern Reglai is overestimating the proportion of devoicing. So women still devoice more than men, but it turns out that these red dots should be a little bit higher. So Northern Reglai preserves a little more voicing than what I have on this slide, and the exact results are coming up soon. If you're interested, I can send them to you in a few weeks. Okay. Now, let's look at the secondary acoustic property of voicing in Northern Reglai. So those that are realized on the vowel. So we have a pitch difference between the vowels following the voiceless stops and the vowels following the voice stops. So at vowel onset, F0 is lower after voice stops, which is what we expect from Western languages. But you can see that there's a kind of ballistic effect in that, and that after a few milliseconds, the effect reverses and F0 becomes higher and after voice stops than voiceless stops. Okay. Note as well that this difference is relatively small. We're talking about at most a 15 hertz difference. There is a difference in voice quality as well. So if you look at H1 minus H2, you can see that this indicator is higher after voice stops than after voiceless stops, indicating that the voice quality of the vowel following voiceless stops is breathier. Okay. The difference is not very large, however. It's about 2 decibels. We're going to see that there are languages in which the difference is much larger. And then the last 2 panels represent vowel quality. So F1 here, which is a correlate of vowel height, and F2, which represents vowel frontness. And you can see that in A and in mid vowels, F1 seems to be a tiny bit lower after voice stops than after voiceless stops, but that there's not much of a difference in high vowels in E and U. Okay, so there seems to be a slight effect of voicing in F1, but it's very moderate. Even for A, the difference would be of about 100 hertz, which would be comparable to what is found in English. Okay, for F2, results seem to be more variable, but actually these lines hide an enormous amount of variation. So most of the differences that are found here are not significant. Okay, so now let's move on to the other languages that all pattern in similar ways. So on the next few slides, I'm going to have the 2 Monkmer languages in the first 2 boxes and the 4 Chamic languages in the other boxes. Okay, so what's interesting here is that while the voiceless stops always have a positive VOT, okay, so you can see that the reddish pinkish distribution is always above 0 in all these languages. The voice stops in blue have a bimodal distribution. Some of their tokens are below 0, indicating that there is true voicing or closure voicing. But in all of these languages, a significant, most of the time, a dominant proportion of the voice stops are realized with a positive VOT. So this indicates that in these languages, voice stops have already been devoiced for the most part. And for this reason, instead of talking about voiced voice stops and devoiced voice stops, which would be confusing, I'm going to use the register labels. I'm going to use high register to talk about the syllables that previously have voiceless stops, and I'm going to talk about the low register to talk about syllables that previously had voice stops. Okay. Now, if we break this down by speaker, we can see a lot of individual variation. Okay, so Chrau, Southern Reglai, Eastern Jarai, and Western Jarai are not that interesting in that the individual variation doesn't seem to be structured. So if you look at the regression lines here in Southern Reglai, Eastern Jarai, and Chrau, they're relatively flat. And the difference we find in Western, and the regression line in Western Jarai is not significant. Okay, so it seems that the variation cannot be explained by sex or by age. Age is on the x-axis. In Mönong and Chru, we have something different. It seems that in both of these languages, you have much more voicing in male speakers, especially older male speakers, and much less voicing in female speakers, and especially younger female speakers. So this seems to be change in progress. It seems that younger women are leading the change and that older men are more conservative. So this would be the typical sociolinguistic change scenario. I'm not going to have very much time to talk about this today, but if you're interested, there's our paper on Chru in which we describe these results was just accepted with minor revisions in the Journal of Laboratory Phonology yesterday. So I could send you the draft if you're interested in seeing the details. What seems to be common to all these languages is that women, the red circles, tend to have more devoicing than men, the blue greenish triangles. Okay, so even in languages in which there is less voicing, there seems to be a slight tendency. Okay, and we believe this may be for anatomical differences. It would be very surprising if all languages had the same sociolinguistic patterning. Okay, so now let's look at the secondary acoustic properties of voicing. So let's start with pitch. So you can see that in Chrau and in Chru, you have a much higher F0 in the high register than in the low register. So after stops that were previously previously voiceless versus the stops that were previously voiced. In Monong, you have a similar pattern, but it's not significant. In Eastern Jarai and Western Jarai, there doesn't seem to be very much of a difference between the two registers. And in Southern Reglai, you actually have the opposite pattern. So this seems to indicate that, contrary to most description of register that are available in the literature, F0 may not be such a reliable cue of register. It may be found in some languages, but not in others. Voice quality seems to be much more robust. So in all 6 languages in which there is devoicing of voice stops, you can see that the low register that comes from original voice stops is much breathier than the high register that comes from original voiceless stops. Okay, you can see here in Chru that the difference is not that big. We're talking about 4 or 5 decibels, but that's still relatively salient. And importantly, that's already much more salient than what we found in Northern Reglai, the language that preserves voicing, in which the difference was about 2 decibels. Okay. So let's look at vowel quality now. In terms of vowel height, it seems that in all the languages in which there is a significant devoicing of voice stops, you have a lower F1 in the low register, so after previously voice stops. Okay, and this seems to be this effect seems to be much stronger in the low vowels like a, or in the low mid vowels like e and o, than in the high vowels. And that's something that has been described repeatedly in the register languages that have been studied by other authors. So this is not surprising at all, despite the fact that we don't really know what the cause of this effect is. Differences in F2 are much smaller. They seem to be fairly consistent overall, which is surprising. So it seems that F2 is higher in the low register than in the high register. But note that the difference is not as strong. The magnitude of the effect is not as strong as for vowel height. Okay. So it's been about 45 minutes, so I'll answer my questions. So how is voicing realized in Montclair and Chamic? So we see, if we look at voicing itself, so the realization of vocal fold vibrations on onset stops, you see that Northern Reglai has a much higher proportion of voice stops than all the other languages in the sample. But even among these languages, there is some variation. You can also note that language family doesn't seem to explain differences. The Montclair languages are in yellow and the Chamic languages are in red, so they're all over the spectrum. And that there are some surprising differences. So Northern and Southern Reglai, which are mutually intelligible despite the fact that they're different dialects, are at different ends of the spectrum. What's also interesting is that Chru seems to be fairly mutually intelligible with Southern Reglai, and it's in the middle of the spectrum. Another interesting result is that, as I mentioned before, in all of the languages with significant voicing, voicing is more prevalent in men than women. It seems that women tend to devoice their voice stop more than men, and there is some partial evidence that this is also the case in other languages. So a few weeks ago, Alexandra Pfeiffer gave a talk about Afrikaans, where she shows that men retain voicing much more than women. And there are studies of Indiana English and Chicano English that show that women also tend to devoice obstruents a little more. Now, does the type of voicing we're finding in Northern Reglai look like true voicing in other languages, by which I largely mean Western European languages? Well, it seems that it looks like it to a certain extent, but there is more devoicing, and women tend to devoice more than they would do in Western European languages. So second question, if the voicing contrast is preserved, what are its secondary acoustic properties, and do they match what we know about register? So in Northern Reglai, the only language in which the voicing contrast can be said to be preserved, or to a significant extent. So voicing conditions a weak F0 effect at the onset of the following vowels. So F0 is higher after voiceless stops than after voice stops. So this is just like French, English, Spanish, and most Western European languages. We also see that voicing conditions a weak F1 effect at the onset of the following vowel. So F1 is higher after voice stops, which is also what we find in Western European languages. F2 differences are messy and not necessarily that significant, so I'm not going to spend too much time on them. What's important here is that voice quality difference in all the Southeast Asian languages we've looked at seem to be different from what was found in Western European languages. There's more breathiness after voice stops than after voiceless stops, whereas in English, for example, there's more breathiness after voiceless stop than after voice stops. And in French and Spanish, there's usually not that much of a difference in terms of breathiness. Okay, so the fact that there is more breathiness after voice stops than after voiceless stops is similar to what is found in the other languages, those in which voicing is lost. I mean, the mainland Southeast Asian languages in which voicing is lost, but the spectral slope difference between voiced and voiceless stops is much smaller in Northern Reglai than the other languages. Final question, if voicing is lost, is register realized as expected from research on previous languages? So there's two expected results here. So the low register is breathier in all 6 languages in which the voicing contrast is optional, or in which it's largely lost, with some interlanguage variation. And then in terms of vowel quality, we see that it is a robust indicator in all 6 languages in which the voicing contrast is lost or tends to be lost. So in terms of F1, we see that vowels have high on-glides in the low register in all 6 languages. And we also see that on-glides are consistently more pronounced in low vowels. And even if F2 differences are smaller and often not significant, F2 tends to be higher in the low register. What is unexpected is that F0 is higher in the high register in Chrau, Mnong, and Chru, but lower in the high register in Southern Reglai and in the 2 Jarai dialects, even if it's not necessarily significant. So this goes against much of the literature on register, but there is one paper by Whalen and Youngman where they spent a lot of time looking at individual variation between Chantaburi Khmer speakers. And it seems that in that language, at least, F0 is not a very consistent cube. So this wouldn't be new. Okay, so there's also some unexpected results that don't necessarily match specific research questions. So devoicing is very common in languages that were previously described as having a voicing contrast. So why would that be? So linguists, mostly SIL people, went to Vietnam and to Cambodia in the 60s and described all these languages with a voicing contrast. And 60 years later, I'm not finding the voicing contrast in most of the languages. Why is that? So could there have been change in progress since the 60s? It could be the case in Chru and Nong. I doubt that change would have been that fast because some of our older speakers were adults when SIL missionary linguists were working in the area. So it seems that these speakers were already around and would have had some devoicing already. But what is certain is that the other languages show little evidence of change in progress. So they should have had devoicing for a long time, or devoicing should have been stable in these languages for more than 60 years. So why did SIL linguists miss voicing? So since the low register shares many property with onset voicing in Western languages, and since it's sometimes accompanied by voicing, as we've seen in the result, it's possible that these linguists took voicing as the closest descriptive term to what they were hearing. So voicing was the closest thing they knew to register that they have available in their catalogs of contrast. And maybe that's the reason why they describe these languages as having a voicing contrast. Another possible factor is that most of them were native speakers of English, a language in which voice stops don't have onset voicing. So it's possible that it made it easier for these linguists to perceive voice stops as the low register stops as being voiced, because they don't necessarily associate voicing with they don't necessarily associate vocal fold vibrations with the voicing contrast. The fact that another possible factor is that most SIL researchers were men and worked exclusively with men, since men preserve more voicing than women that would have biased or tilted their results towards voicing, whereas the community as a whole may already have had significant devoicing at the time where they worked. I've been in touch with two SIL linguists, Ernest Lee and Ken Gregerson. And they can't necessarily give me a full picture of what was happening at the time, but what seems to be clear is that especially in the early 60s, they didn't have a very clear idea of what register was. People were talking about it, but it hadn't congealed into a clear type of well-described phonological contrast. So the fact that there is a lot of devoicing is especially surprising for Chamic, because it's a family where voicing neutralization was until now considered the exception. It was believed that out of 7 Chamic languages, 5 were still preserving a voicing contrast. And after doing work on most of these varieties, it seemed that the only language that really preserves it is Northern Regli. So what are the phonetic implications of this? Is voicing in mainland Southeast Asia the same type of laryngeal contrast as that described in Western European languages? So a first problem is that there are no attested cases of registrogenesis or register development out of voicing in languages that previously had true voicing outside Southeast Asia. So this would be evidence that maybe we're looking at a different animal. Maybe voicing in Monkmer and Chamic is not the same as true voicing in Western European languages. Second, in Southeast Asian languages, it's clear that breathiness is associated with voicing, while in Western European languages, it's associated with voicelessness. So another reason to believe that we may be looking at a slightly different type of laryngeal setting. So this raises a question. Is it possible that the low register favors the production of closure voicing? So is it possible that in the 6 languages in which there's very little voicing, register is primary, and the voicing we occasionally see during the onset stop, the closure of the onset stop, is actually a co-articulatory effect of register, of the low register. So this is something that was suggested by Madison in 1978. So basically, if the articulatory mechanisms involved in the production of the low register, like larynx lowering and tongue root advancement, boost transglottal pressure while the glottis is adducted, maybe voicing could be a side effect of register production, rather than register being a diachronic effect of an original voicing contrast. And then if register doesn't derive from voicing, the fact that breathiness is associated with voicing and that F0 is not consistently associated with register is not really a problem anymore, okay? Because we wouldn't have to explain why the acoustic properties on vowels following the voicing contrast are different in the 2 areas. We simply wouldn't be looking at the exact same type of laryngeal contrast on consonants. So this is speculative, and I'd like to have your feedback on this. This is relatively early, but if it's true that register is somehow primary and that voicing is a side effect of register in many Southeast Asian languages, and the question is still open. I definitely don't have definite answers here. This would have diachronic implications. So first, was there ever a true voicing contrast without register in Mon Khmer? So perhaps register is primary in Mon Khmer and register is reconstructible to Proto-Mon Khmer instead of voicing, and that register did not develop from voicing in Mon Khmer languages. So this is something that was actually proposed by Georges Maspero in a grammar of Khmer that dates back from 1915. So what he's proposing is that in Mon Khmer languages, register could be the primary contrast and voicing would come and go during the course of the history of the language and wouldn't necessarily be constant. What would be relatively constant would be the register contrast itself. If it were the case, Audricourt's 1954 classical model of Vietnamese tonogenesis, which was then generalized to Chinese and to Thai languages, may need to be revisited. It seems that the roots of the two-way tone split may have been present early on. So there may have been a register contrast very early, even before the development of the three basic tones. And this is what we seem to see in small Vedic languages. Vietnamese has sister languages that are spoken at the border between Vietnam and Laos in Nghệ An province in north central Vietnam. And it seems that these languages have three tones that are combined with a two-way voice quality difference. So this is, I would really like to be able to make that claim. It's probably too early to make it in a definite way. And one of the reasons why the story doesn't fully work is that Chamic seems to be more complicated. So why? We know that the Austronesian languages that are closely related to Chamic, that are mostly Malayic languages, have a true voicing contrast. So we can assume that at some point in its history, Chamic also had true voicing. How did it develop a contrast that is so similar to Mon Khmer? So perhaps it is due to the history of Chamic. There is linguistic evidence and genetic evidence that at a very early stage, Chamic speakers came from Borneo and settled in central Vietnam, but that these speakers were mostly man and that there were relatively few of them, a few hundred people, maybe a small group. Now, if they massively took Mon Khmer wives and established a community in South Central Vietnam, it's very possible that there was a massive influx of Mon Khmer speakers from the start. And if there was continuous contact with Mon Khmer over the following 2,000 years, it's possible that there was, that basically the Chamic voicing contrast was replaced by the register contrast that was found in the L1 of all these new speakers. If this was the case, Chamic would relatively early on have developed a register contrast similar to Mon Khmer, may have preserved voicing as well, may have preserved voicing as a redundant cue, but the primary cue would have been register. The problem if we claim this is Northern Reglai. So making that claim would force us to claim that Northern Reglai then lost its register contrast and replaced it with a voicing contrast. And this is not something we have any evidence for. Okay, so that's all for my talk. I'll answer your questions now.
Thank you very much, Marc. And your daughter was very cute. So listen, Stephen is going to stop the recording now. We're not going to record the questions. Okay, some people might need to leave.